With our chapter 12 vocabulary. So in other words, we're talking about circles. We'll just get right into it. So our first word is, it's taking me a while to get used to this, circle. Circle with an E. So make this a little bit thicker here. A circle is the set of all points equidistant from a given point called the center. So here is the center, and every part of here is equidistant from that center P, so that forms a circle. A lot of these words you know already. So the next one would be a radius. So a radius is a segment with one endpoint on the center, so right there, and the other endpoint on the circle. So that is a radius, R. The next one, diameter. So diameter is a segment that has both endpoints on the circle, so here and here, and it goes through the center. So that is our diameter. So notice that the radius is here. I mean, this could also be a radius. That's also radius R. This is also a radius R. And starting here from the center, this is also radius R. But this is the diameter. This is the diameter D. So the diameter equals 2 times the radius. So diameter equals 2 times the radius. Whenever you see diameter, you can also use 2 times the radius. All right, so that should be a review. The next one is something that might be a little bit newer. This is something called a central angle. So a central angle is an angle whose vertex is in the center of the circle. So let me scoot on over here and see how I do this. Push the thingy. No, that zooms out. Slide the thingy over. And somehow it got cut off. All right, well, I'll be working the kinks out of this as we go, but anyway, so over here at circle, got cut off a little bit. Circle we can name, excuse me, with the center of the circle, so we can call this circle P. Let me give it a little thing there, symbol, circle P. This is called circle P. The radius, I mean, there's tons of them here, infinitely many, but we'll call it PB is one of them, right? A radius. PB is one of the radii. Also PA is one, PC. Diameter, AB. AB is a diameter. And central angle. So central angle is any angle formed with the vertex being the center. So for example, this is a central angle. So angle CPA. Angle CPA is a central angle. Back up here. So, bless you. So before we move on and talk about the central angle a little bit more, the next word is an arc. So an arc is part of the circles on the outside. Any part of the circle. It could be a semicircle. Right? A semicircle is half of the circle. It could be a minor arc. Minor arc is smaller than a semicircle. So a semicircle is, since the whole circle is 360 degrees, a semicircle would be 180 degrees, right? So a minor arc is anything less than that, anything less than 180 degrees. And a major arc would be something greater than 180 degrees. So if we were to point out a semicircle here, for example, here is one. It starts here, it goes all the way around, finishes right there. So that's halfway. There's a diameter, so it's kind of tracing right where that diameter went. Now, we talk about arcs. We usually, we're going to use 3 letters here. Arc A, C, E, and we're going to put this little rainbow above it. Arc ACE, ACE. That's a semicircle. The reason we put C here is if you just put AE, we're not sure if you go this way or if you went this way. I mean, this is also a semicircle. Arc AD is also a semicircle. A minor arc. Let me change colors here. Well, anything less than that. So, for example, this is a minor arc, AD. Arc AD, we're not going to use 3 letters because we only have 2 of them available to use. A major arc would be something that's greater than 180 degrees. So, for example, I could use starting from here all the way over to here. Ooh. So that would be arc ADC. Right? ADC. We're just going to use 3 letters, or 2, but 3 when possible. Arc ADC. You could also say arc AEC. ADC. It's our major arc. Okay. So the connection between the 2 things we just talked about, an arc and a central angle, is that the arc degree is going to be exactly the same as the measure of the central angle. You might have figured that out because if you think about it, this measure of this straight angle, right? This straight angle is 180 degrees. But if you look at the arc that goes with that central angle, it is also 180 degrees. So it's the same. Any central angle and its intercepted arc are going to be the same. So if we come up here, and I'm sorry, again, these are cut off, I'll figure these out. Arc ST, let's put the rainbow over there. Arc ST, let's see where that is. Arc ST is right here. So what would the measure of arc ST be? Well, it's nice because we have a central angle. Remember, central angle means the vertex is right here in the center. It's 86. So this is also going to be 86 degrees. Let's see, RQ, arc RQ. Let's put the rainbow here. Arc RQ is going to be from here to here. Oh, and again, we have a nice central angle, 145 degrees. That's obtuse. 145 degrees here, so arc RQ is 145 degrees. Now these are not always super easy like we just did here. For example, arc RST, we have to do a little bit more work. Let's take a look. RST, we'll do a different color. Red. Arc RST. Alright, what's that going to be? Well, we know it's going to be 86 from this part, plus this. Well, the question is, what is this going to be? Let's think about it. Well, if we know we have a diameter here, this is a semicircle out here, so we know this whole thing must be 180 degrees, right? This whole thing must be 180 degrees. So if we say 180 degrees minus this piece right here, we'll be left over with this red piece, right? This whole thing is 180. So if we subtract out 145, that'll be this piece right here. 180 minus 145. Well, 100 minus 100 is 0. And 80 minus 45. 80 minus 40 is 40. So 80 minus 45 is 40 minus 5 more, so 35. So this right here is going to be 35 degrees. So the total of arc RST is going to be this piece, 86, this arc, and this arc, 86 plus 35. 86 plus 35, that's going to be 121 degrees. So this is still a minor arc, it's still less than 180 degrees, but we had to do a little bit more work to find this arc. Okay, continuing on here. So the next one is pi. Okay, I guess we're going with red. Pi, and that is a symbol. Pi. And pi is approximately, of course, 3.141592653, blah, blah, goes on forever and ever. No, it's a transcendental number. It never finishes. But really, what is pi? Pi is just a ratio. Remember, a ratio is just a comparison of 2 numbers. It's the ratio of a circle's circumference to diameter. So no matter what size the circle is, if you measure the circumference, and you divide that by this diameter, circumference over diameter, you're always going to get pi. Always this 3.14159 dot 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 number. So, of course, you might have approximated it in the past using 3.14 or 22/7. These are just approximations. This is not actually pi. We'll be using the symbol most of the time in this class. Just as a review, circumference is the distance around a circle. So circumference, as this diagram indicates, is if you travel all the way around here and measuring it like with a string, straighten out and measure it, it's going to give you the circumference. Okay, so and again, if you take this number, the circumference, you divide it by the diameter, circumference over diameter gives you pi. Okay, so if you want to, let's just write that. So circumference equals circumference over diameter equals pi. All right, but let's say we just want to find the circumference. How do we get this c by itself? Well, we just take and we're dividing by d right now, right? So we're just going to multiply both sides by d. Right, d over d is an equivalent form of 1. So the circumference, if you want to find the circumference, is just diameter times pi. Right, the circumference equals the diameter times pi. Right, diameter times pi. But remember, we talked about the diameter is really just 2 radiuses, right? 2r. So, so if you want to substitute, instead of saying diameter, if you want to say 2 radiuses, so you could say 2 times the radius times pi. That's fine. But usually we say, instead of 2r pi, we like to put the pi first because multiplication is commutative. We say 2 pi r. So the circumference equals the diameter times pi, or if you like to use 2 radius, circumference equals 2 pi r. Okay, so you want to find this distance around, diameter times pi or 2 pi r, either way. And of course the other one, I guess we're going back to blue, is area of a circle. Area of a circle is of course the amount of square units inside a circle. Video, I'll show that to you later. But basically, how do you count the number of square units inside this? And there will be something I will show you later exactly how to do it. But just as a preview, let's come over here. Pretend you had to take all these guys and you wanted to open it up flat. Open it up flat. What you can kind of see here is, remember this is the radius. So that ends up being this radius. And then you want to multiply by this because this is almost like a rectangle shape here. And this is going to be pi times the radius. Pi times the radius. Okay, and remember, this looking like a rectangle, not quite, and I'll show you in the video how it exactly turns into a rectangle. But remember, to find the area of a rectangle, just multiply these two. So if you multiply r times r, you get r squared. So the area of a circle is pi r squared. Pi r squared. Let's come back here. So the area of a circle. Area of a circle equals pi times the radius squared. Okay, and we'll use these guys. All right, so why don't we do some of these problems together. So taking a look here, it says name the arc made by the given angle. So major arc, means it's greater than 180 degrees. For angle SQT, let's find angle SQT. SQT is right here. And so the arc that goes along with this angle would be this guy right here. There's only 2 letters, so we're going to name him as arc ST. Arc ST. Let's see here. We'll do the odds. So we'll do the odds. Name the central angle of the given arc. All right, so remember, this is the arc. This is the central angle. Let's come down here. So arc WV. WV right there. So what would the central angle be? Well, that would be this guy right here. So we could name this guy angle VQW. Or you could, of course, WQV. it doesn't matter, one or the other. Don't forget, again, the key aspect of the central angle and the arc are going to be the same degree measurement. Let's see, arc LJK. LJK. So you follow the J here. LJK. That's the arc. Okay, what is the central angle that goes with this? It's kind of different to see here, but it's going to be this angle right here. Even though it doesn't look normal, that's okay. It's an obtuse angle. It's an obtuse angle. That's okay. That's angle LQK. LQK. Or you call it angle KQL. Either way. All right. Looking down here, find the measure of the arc or central angle indicated. So assume that the lines which are diameters are actual diameters. In other words, that's saying a diameter should go through the center. We can assume that this guy right here is a diameter. So let's look at number 7. Let's find the measure of this angle, angle XST. Let's find where that is first. XST, XST, right here. What is that? Okay, so remember, what we have to remember for this is that the arc and central angle are going to be equal to each other. They're the same measurement. So if I can find this guy, since I know that they're the same, then I know what this angle is. So let's go and take a look and say, okay, since this is, see how this guy goes straight through the middle here? This is a diameter, so this right here is going to be a semicircle. Right, that's a semicircle. That's 180 degrees. Right, we know that's 180 degrees. So if we take this 180 and we subtract out this piece, 180 minus 49, so we're going to borrow here. That's going to be 10 minus 9 is 1, 7 tens minus 4 tens is 3 tens, 131. Right, 100, so this is 131 degrees. So 131 plus 49, that's where the 180 comes from. And if this is 131, then this is also going to be 100. Let me erase the question mark here. This is also going to be 131. So angle XST equals 131 degrees. All right. As you're thinking about that, let's go ahead and take a look at this number 9 here. Measure of angle JML. JML. So where is that? Angle JML. This whole thing right here. This whole angle. So what you want to do is, again, find the intercepted arc of this angle. I'm just going to trace it out. These are going to be the same. Central angle and its intercepted arc are going to be the same. So all we got to do is find this guy, and then we've got this guy. All right, let's see if we can figure out where our diameter is. Maybe we could use that. Any diameters here? No 180 degrees. Oh, but I've got, let's see, I've got this is 30, okay, I've got this is 85. I just need to know what this is. What this is. Well, what we can do is, see this over here, this is not just information. We can actually use these pieces as well. Okay, I've got almost everything labeled. I just don't know what this is right here. So we know that instead of using diameter, let's use the fact that the entire circle, all the way around, is going to be 360 degrees, right? 360 degrees. So if I could take 360 degrees and subtract out all of these guys, I could find this missing piece. So, I mean, you can call this x if you want. You could say something like x plus 85 plus 125 plus 75 plus 30 equals 360. Or you could just subtract it all out. Right? This plus this plus this plus this plus this equals 360. We don't have 180 degrees because there's no diameter, no straight line through the center like we did last time. Okay, so let's go ahead and just add these up. So 75 and 30, that's 105. 85 and 125. Well, let's see, 5 plus 5 is 10. 80 plus 120. 80 plus 120 is 200, so we get 210. Okay, let's add this up. 200 plus 100 is 300. 10 plus 5 is 15. So x plus 315 equals 360. Okay, we'll subtract out 315 from both sides. And let's see, x is going to give us, let's see, 60 minus, so 300 minus 300 is 0. 60 minus 10 is going to give us 50, and then minus 5 more is 45. Or you could just do the subtraction algorithm here. So 45. So if this is 45 degrees, that means that this is also going to be 45 degrees. So now that we know what this is, we can finally figure out what is the entire angle going to be, right? So we filled in this because we needed it to find the whole angle here. Remember, we're going from here to here. The answer is not just 45, right? It's not just this. So it's going to be, our answer is going to be 85 right here plus 45 plus 30, right? So angle JML equals 85 plus 45 plus 30. And let's see, 85 plus 45, 80 plus 40 is 120, 5 plus 5 is 10, so 130 plus 30. And 130 plus 30 is going to give us 160. So our angle JML, this whole guy right here, is the same as this arc right here because the central angle is the same as its intercepted arc. We did some work to find that this was 45, and then we added them all up. Okay, so let's keep going now. So this time, we don't want to find, for number 11, the angle. We want to find this arc, right? This is an arc, FHJ. FHJ. So we start at F, trace it along, FHJ. Okay, what is that going to be? Well, this one is not so bad here. I mean, you're given that this is 90, right? If this is 90, then you know that this piece right here, I'll do it in red. If you know this is 90, then you know that this is also going to be 90. But you actually don't even really need that because look, we've got, see how this goes straight through the center here? This goes straight through the center. That means that this piece right here, this arc from here to here is a diameter, right? Sorry, this is a semicircle, excuse me. This is a diameter, this is semicircle, so this is 180. We don't even need to worry about this 90 business. This is 180. Oh, this is 45. So to get the entire arc, we just do 180 plus 45. 180 plus 45, which gives us 225. Oops. Okay. Moving along to number 13, says find the circumference of each circle. The circumference is, again, the measure of the area all the way around. So remember the circumference. We talked about how, first, actually, let me step back. We talked about how pi is always going to be the ratio of the circumference over the diameter. So how do we get the circumference by itself? You multiply both sides by d, and you get diameter times pi equals circumference, right? So the way to find circumference is diameter times pi. Or, since the diameter is just 2 times the radius, you can say 2 pi r. Either one of these will work. Diameter times pi or 2 pi r. I'm just going to stick with the diameter times pi. So here we go. This is obviously only half. This is a radius. So if I wanted to find the diameter, what would the diameter be? Well, this is 12. This would be 12. So my diameter would be 12 plus 12, or 24 yards. So the circumference would be 24 pi. Right? Diameter and times. You don't need the times here. 24 pi yards. Let me see if I get the calculator. Nah, forget it. 24 pi yards. And that's all you need. Okay, coming down here to number 15. Circumference equals diameter times pi. So look, here it is. This is a diameter. This is a diameter. It's all the way across. So we just use this 4 right here. So circumference equals diameter times pi. And let's put the units 4 pi meters. Okay. Now, let's come down here. This is going to be a little bit different now, finding the area. Now remember, area is going to be, we just shaded, it would be as if you were trying to find squares inside this guy. So if this is 4 feet, how many square feet are there going to be inside? So really you're measuring kind of the whole inside space of this circle. So remember this area formula is area equals pi r squared. Excuse me. Pi r, excuse me. So let's take a look at what we have here. We need the radius, not the diameter. Excuse me. So we've got area equals, and luckily for us, we're given the radius here, r, halfway across. So this is 4, so pi times 4 squared. And 4 squared, it's not 8, remember 4 squared is 4 times 4, so 4 squared equals 16. So area equals 16 pi. We usually like to put the pi second. And this is in feet. And because we're measuring square units, right, square units, we're going to put 16 pi feet squared. And if you have your calculator, I mean, you could punch in to see what that would be approximately, but this is fine just to leave it like that. Let me just try it on mine. 16 times pi is going to give me approximately, whoa. So if you punch that in your calculator, you can get an approximation that is approximately 50.265 feet squared. But I care more about this one. So in other words, you could make 50 of these. I drew the squares a little bit too big. About 50 of these square feet would fit inside this circle. Okay, number 19. Again, we're finding the area. So area equals pi r squared, our radius. Now, careful here. This is the diameter. This is all the way across. We want the radius. So this is the radius. What is the radius? Well, if the whole way across is 16, we just divide 16 by 2 and we get radius equals 8. Right? 8 feet. So the area equals pi times 8 squared. So our area equals pi times 8 is 64. But we like to put it 64 pi, and this is again feet squared. And you can leave your answer like this. If you have a calculator, you can punch in 64 times pi to get an approximation. I'll do that, and we get area equals approximately 201.062 feet squared. So in other words, you could fit 201 of these square feet, blah, 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 inside this circle. It's all in the inside area.